Hey everyone, welcome back to Opticity Embedded Sphere. In today's video, we'll be building a weather monitoring system that sends live environmental data, including temperature, humidity, pressure, and altitude, straight to the TeamSpeak IoT platform. We'll be using an Arduino Uno as the main controller, along with a DHT sensor for temperature and humidity, a BMP180 sensor for pressure and altitude, and the ESP01 Wi-Fi module to wirelessly upload our readings to the cloud. By the end of this video, you will have your very own IoT-enabled weather station, perfect for remote sensing, smart environment, or just learning how to bring sensors and the internet together. Before we get started, let's quickly go over some basic concepts about the ESP01 Wi-Fi module. The ESP01 is a compact Wi-Fi module based on ESP8266 chip. It allows microcontroller like the Arduino to connect to the internet over Wi-Fi. It communicates with the Arduino using 80 commands over serial TX/RX. These commands let you connect to a Wi-Fi network, open TCP or HTTP connections, send and receive data from web services like TeamSpeak, Blink, or custom servers. Although small in size, it's a powerful and affordable solution for adding wireless communication to embedded projects like IoT sensors, home automation systems, and remote data loggers. Here is a short description of our TeamSpeak. So the TeamSpeak is an open source IoT platform that allows you to connect, store, analyze, and visualize sensor data in real time. It's especially useful for projects involving Arduino, ESP8266, ESP32, and other microcontrollers. With TeamSpeak, you can create channels to store your data, set up feeds for different types of readings like temperature, humidity, etc. View live graphs of your data online, even use MATLAB for advanced data analysis or trigger events based on condition. It's widely used in educational and DIY projects for monitoring environments remotely. Let's take a look at the components you will need for this project. An Arduino Uno, ESP01 Wi-Fi module, DHT temperature and humidity sensor, BMP180 sensor, breadboard, jumper wires, 10 kilo ohm resistor, and three 1 kilo ohm resistors. You can find the link to purchase all these components in the description box below. Let's begin by wiring the ESP01 to the Arduino Uno. Connect the VCC, CHPD, that's the chip enable, reset GPIO pin of the ESP01 to the 5-volt pin of the Arduino. So we have our VCC. Connect the ground pin of the ESP01 to the ground of the Arduino. Then connect the TX pin of the ESP01 to digital pin 11 on the Arduino. Okay, the RX pin on the ESP01 operates at 3.3 logic, while the Arduino output 5 volt on its digital pin. To prevent damage to the ESP01, we will use a voltage divider. Connect a 1 kilo ohm between pin 10 of the Arduino and the RX pin of the ESP01. Next, take additional 1 kilo ohm and connect them in series. Join one end of this resistor chain to the same junction where the first resistor and the ESP01 pin meets. Connect the other end of the resistor chain to ground. Okay, so let's do that now. Reduces the 5 volt signal down to a safe 3.3 level for the ESP01 RX pin. Now let's wire the DHT sensor. Connect the VCC pin of the DHT. The VCC pin of the DHT to 5 volt on the Arduino. Then connect the data pin of the DHT to digital pin 5 on the Arduino. Then connect the ground pin to ground pin on the Arduino. To ensure stable communication, place a 10 kilo ohm resistor between the VCC pin and the data pin of the DHT sensor. So let's wire the BMP sensor. Let's connect the BMP sensor to the Arduino. Connect the VCC pin of the BMP to 3.3 on the Arduino. So we have 3.3. Then connect the ground of the BMP to the ground of the Arduino. Then connect the SCL to pin A5 because that's also SCL on the Arduino, and you connect SDA to pin A4. This allows the Arduino to communicate with the BMP 180 over the I2C communication protocol. Before we upload any data, let's first set up our TeamSpeak account and create a channel where our sensor readings will be sent. Before we upload any data, let's first set up our TeamSpeak account and create a channel where our sensor readings will be sent. Step 1, create a TeamSpeak account. You go to www.teamspeak.com, click on the sign up button in the top right corner. If you already have a MathWork account, you can sign in directly. Otherwise, click create one and follow the instruction to set up a free account. So step 2, create a new channel. Once you've logged in, click on channels in the top menu and you click on my channel. Then click on new channel to start setting up your data stream. Under name, give your channel a title. Next, scroll down to the field section and enable 4 fields. Field 1, name it temperature. Field 2, name it humidity. Field 3, name it pressure. Field 4, name it altitude. You can also enter a short description for your project if you like. Leave the rest of the setting as they are for now and click on Save Channel at the bottom. Step 3. Get your API key. Once the channel is saved, click on the API keys tab at the top. Here you will see your right API key. Copy it. You will need this key to send data from your Arduino. Let's now go through the code step by step and understand how it works. We have include software serial, Wi-Fi.h, Adafruit, BMP 085.h, DHT.h. We begin by including all the libraries. Software serial.h allows us to create a serial port on any 2 digital pins to communicate with the ESP01. Wire.h enables I2C communication used by the BMP 180 sensor. Adafruit underscore BMP 085.h for interfacing with the BMP 180 pressure sensor. DHT.h used for the DHT temperature and humidity sensor. Then we also have where we declared for the object and the pins. So we have ESP 11,10. It creates a software serial connection for the ESP01. Pin 11 is RX received from the ESP, and pin 10 is TX sent to the ESP. Then we have our DHT sensor is connected to pin 5 and we define it using the DHT library. We also have an object for the sensor, that's DHT pin, DHT type, and also Adafruit BMP05 BMP. These lines initialize the DHT and BMP sensor objects so we can read values from them later in the code. Then for our credentials, we'll have our SSID, our password, and our API key. We also have our hosts. As you can see, api.teamspeak.com. We store our Wi-Fi name, password, TeamSpeak, API key, and the host URL in string variables. Ensure to add in your own Wi-Fi name, password, and right API key from the channel you created. Then we have a struct that contains our temperature, humidity, pressure, and altitude. The name of the struct is weather. We create a struct called weather to hold all the values we need from our sensors, which are temperature, humidity, pressure, and altitude. Then for our setup function, we have serial communication where we initialize both for the Arduino and the ESP01 using our software serial. Both sensors are initialized. Finally, we connect the ESP01 to the Wi-Fi using a custom function, connect to Wi-Fi. Then we go to our main loop. Every 20 seconds, get weather data. It collects new sensor data. Then we have another function that is send data to TeamSpeak. Upload the value to your TeamSpeak channels. Then let's go to our get weather data function. This function collects data from DHT and BMP 180 sensors. So the read temperature gets temperature in degrees Celsius. The read humidity gets humidity in percentile. Then we have atmospheric pressure in Pascal. We have real altitude, estimate altitude based on pressure. Then we print each value to the serial monitor for debugging purpose, which is what we did here. Then we are returning the whole value. Then we also go to our send data to TeamSpeak. If you can see, we construct a HTTP GET request with all sensor values included as field. Then we sent several AT commands to the ESP01. We have AT plus CIP MUX equals to 1, enables multiple connection. We have AT plus CIP start equals to 0, TCP, etc., which opens a TCP connection to TeamSpeak. Then we have AT plus CIP send equals to 0, tells ESP we're about to send. We send the actual HTTP request using esp.print. esp.print get data. Finally, we close the connection with AT plus CIP close equals to 0. Then we also have connect to Wi-Fi. So in our connect to Wi-Fi, we send 3 AT commands to check communication with ESP, set Wi-Fi mode to station, connect to our router using SSID and password. Then we also have send command. For our send command, this function send AT command to the ESP01, wait up to max time, which is this place, max time seconds for response, check if the expected reply, e.g. OK, is received, print either successful or error in debugging. So you can see either successful or error in reply. Okay. Now that you understand the code and how it works, it's time to upload it to your Arduino. Connect your Arduino Uno to your computer using a USB. Open your Arduino IDE. Make sure the correct board and COM port are selected. Click the upload button. Once the upload is complete, open the serial monitor at 9600 baud, like the baud rate. You should begin to see temperature, humidity, pressure, and altitude readings printed out along with responses from the ESP01 indicating successful data transmission. Then go to your TeamSpeak channel. If everything is working properly, you should start seeing your graph updated in real time. Each field showing the respective sensor values being uploaded every 20 seconds. And that's it. Your weather monitoring system is now live, wirelessly logging data to the cloud using TeamSpeak via the ESP01. In subsequent videos, we'll take this project a step further by transferring everything onto a Vero board for a more permanent and compact build. So make sure you stick around for those updates. You can find all the components used in this project along with the link to the Hoptricity website, where you can purchase them in the description box below. The complete code and freezing circuit diagram are also available there to guide you step by step. Thanks for watching. If you enjoyed this project, make sure to leave a like and don't forget to subscribe for more electronics and tutorial videos.